All right, ladies and gentlemen, here we are on the week 22 test. And we're going to go through the problems front and back. Remember, take really good notes. This is going to help you not only understand the math better, but be more prepared for the next test as well. So let's jump in. In question number 1, let me scroll this just a little bit. There we go. Julie's making a rectangular stained glass mural. She uses silver wire to frame the rectangular mural that has a perimeter of 120 inches. That is an important piece of information. So rectangle, perimeter, 120 inches. She makes a sun frame with copper wire that has a diameter half the width of the rectangle. And this is a how much more question. How much more silver wire will she use compared to the copper wire? We've talked before, anytime you see a how much more question, you think subtract. Somewhere in this problem, at the end, I'm going to have to subtract. So I broke this problem down into 4 easy steps. First, we need to find the width of the rectangle. Now, the reason we need to find the width of the rectangle is we were told that the diameter is half the width of the rectangle. So we need to find its width. And here's the way that we would find the width of the rectangle. We would look and say, okay, we know that the perimeter is 120 inches. They gave us that in the problem. We know that this bottom of the rectangle is 40. So if we know that that's 40, we also know that this top is 40. We don't know the width, so that's x. This side's also going to be x. Which means that if you take 40 plus x plus 40 plus x, you get 120. Perimeter is add all the way around something. Combine like terms, we get 80 plus 2x is 120. Take away the 80 from each side, we get 40 over here. 2x is equal to 40. Divide by 2, and we get x is equal to 20. So we know that this x is 20 inches. Let's take that, shrink it a little bit. We'll leave it down in this corner where you can still see it. That is step number 1. In fact, let me grab my little 1 and just stick it right there. Step number 1. All right, step number 2. Now that we know the width, we need to find out what's the diameter of the sun. Remember that sun made out of copper wire. What's its diameter? So that's where we do part number 2. And part number 2 is, well, they tell us in the problem, the diameter is half of x, diameter half the width, which we said was x. Diameter is half of x. If the x is 20, the diameter of this sun is 10. So remember, diameter is all the way through the center. We know that that is 10 inches. And that is part 2. So let's just shrink that up a bit and put all this together. Stick it right down here. That's part 2. Part 3. Now we know the diameter. We can use that to find the circumference of the sun. Remember, we need the circumference of the sun because we're comparing the perimeter of the rectangle all the way around with the amount of wire, the amount of copper wire used in that sun. So we need to find the circumference. We've already written the circumference formula right up here. Circumference is either equal to pi times the diameter. That's when they give you the diameter. Or circumference is equal to 2 times pi times the radius if they gave us the radius. Well, in this case, they gave us the diameter. We just figured out that's 10. We multiply 3.14 times 10. And we're using 3.14 because they told us right up here, use 3.14 for pi. And we get a circumference of 31.40 inches. All right. So that takes care of that part. Let's stick it right down there with the number 3. Last part. Find the difference. That's that subtraction. Remember we talked about the fact that there would be subtraction eventually. So to find the difference, we're going to use, whoops, my 4 came in pieces. I got to put it together. There we go. We're going to use this last step to find the difference. Take the amount of silver wire they told us in the problem, 120 inches. Subtract the amount of copper wire we just figured out, 31.4, and we get the difference. Julie will need 88.6 inches more silver wire than copper wire. All right, so make sure you've made good notes on this. You can always come back to this. Remember, that's the great thing about video, is at any point you can come back to any of these problems, rework them, look them over again. All right, let's move on to number 2. Problem number 2. So a hiker was last seen near a ranger station in the Green Mountain Forest. Searchers are sent to the area to find the missing hiker. So they give us some information for finding that hiker. First thing they tell us is the hiker can go any direction at a rate of 4 miles per hour and was last seen 2 hours ago. So the first thing is, how far can they travel? Well, they can travel 8 miles. That is 4 miles an hour times 2 hours. The any direction part, that tells us that the shape created by the hiker's path has to be a circle, because they can go this way for 8 miles, this way for 8 miles, that way for 8 miles. Maybe they went, maybe their 8-mile path looked like this. For 8 miles. We don't know, but we do know if they went straight, they could get to the edge of that circle. So now we need to figure out what's the area of that circle. We wrote our area formulas up on top. Area is equal to pi r squared, and a reminder, r squared means r times r. So the area is pi times the radius squared. That's approximately, we're rounding, so approximately 3.14 times 8 squared. 8 squared is 64. We get an area that they would have to search of 200.96 square miles. So that's part 1. Part 2. Well, somebody comes back and says, you know what? The hiker wasn't actually seen 2 hours ago. The hiker was seen 3 hours ago. How much additional area? That's a difference problem again. We're going to think about the fact that there'll be subtraction. So here's the new distance the hiker could travel. Hiker could, instead of going 8 miles, hiker could go 12. Here's the new picture. Represents that. 12 miles any direction. Here's the new math to get what that looks like. The area of this circle, this blue circle now, its area is 452.16 square miles. It grew a bunch. It more than doubled because of that extra hour. The 0.16, that isn't our answer, though. Remember, we're talking about additional. So this is what it looks like when you calculate that. What we're saying is, here was the original that we figured out, 200.96. This blue circle on the outside, that's the new distance the hiker could go. We want the additional. We want the difference in there. To get that difference, here's our math. if we originally said the hiker had gone 200.96, but now we say the hiker goes 252.16, the difference is 251 square miles. All right, so far so good? Great. Let's move on to the back of the page. Okay, I'm just going to let you take a look at this. I would suggest you pause the video because I'm not going to let the video run the whole time, but pause the video, take a look at these answers. One thing to note, write yourself a note on a rectangular prism. All the faces are bases. Definition of a base is, all the faces are bases, exclamation point. Definition of a base is that it is, on a rectangular prism, one of two sides that are congruent, means they're the same size, and coplanar, which means their planes run parallel to each other. So if you put your hand on the top and the bottom of a box, those are both bases. Same size, and they're parallel. Put your hands on the ends of the box, bases. Put your hand in the front and back, bases. So go through, take a look at these. I'm going to pause the video here for a minute. I'll bring over some more of the skew line options because there were other skew lines that this could be. All right, there you go. There are all the skew line combinations we came up with. So you can check through that. We're going to move on to the next problem, but again, you could always pause the video and spend as much time on this problem as you feel like you need to. Here we go on to number 4. So on problem number 4, you've got some angles to find. And what I've done is I have broken those into two parts. The first part, the one that's easy to find, is angle A. Here's the work for angle A. It's 60 degrees. We know that A plus 30 are complementary. They total 90. Take away the 30, you're left with 60. Angle B is more difficult. Here's the answer to B, 56. Let's take a look at the work to find B. So the first thing I did was I labeled some angles all the way down to B. And in fact, let me do it in the order that I thought it. So my thought was, heck, you know what? If I knew this angle, which I'm going to call Z, I would know how much angle B is because these angles are adjacent to each other. So adjacent angles are always the same. Heck, if I know Z, I know B. So how do I get Z? Well, I've got A. If I knew this angle, which I'm going to call Y, then A plus Y plus Z would be 180. Take away A and Y, I'm left with Z. How do I get Y? I thought about the fact that Y plus this angle, which I'm going to call X, these are supplementary. They total 180 degrees. How do I get X? Well, I've got 30. If I knew W, 30 plus W plus X would all be 180. If I knew how much W was, I could take away the 30, take away the W from 180. What would be left over would be X. So that was my path to get there. Here's my work. Here's my work for getting W. W plus 146 represent supplementary angles. So if I just take away the 146 from W, I am left with the measure of, or the 146 away from 180, excuse me, I'm left with the measure of W. Here is angle X, same idea. Now that I know W, I figured out that W was 34 degrees, right there, W. So that plus 30 plus X is 180. Add those together, 64 plus X is 180. Take away the 64, X has to be 116. All right, so now I know X. How do I get Y? Well, once again, same idea. I'm going to use supplementary one more time. 116 plus Y is 180. Take away the 116. Y has to be 64. And then finally, now that we know y, we can get z, because 64 plus 60 plus z all equal 180. 60 was the measure of angle A. 64 was the measure of angle y. A plus y plus z make 180. Take away a and y, which total 124. You get 56. That's z. That's also b, using the idea of adjacent angles. All right, so there you go. That's your explanation for number 4. Review it again if you didn't quite get all of it. And lastly, number 5. So problem 5 is a scale drawing problem. They're asking us to figure out first the original area and perimeter. Well, the original area is 12 square centimeters. 3 times 4, that's how you get area of a rectangle. Multiply length times width. Original perimeter, all the way around, is 14 centimeters. Now we have to apply a scale factor and figure out the size of the new one. So here we go. There we go. Scale factor is 7. So to get this new side, we multiply 7 times the original side of 4. We get 28. To get this new side, we multiply scale factor 7 times the original side of 3 to get 21. And then we can find our new area by multiplying length and width, and our new perimeter by adding all the sides. And there we go. That is your work for problem number 5, and that takes us through the end of the test. So please take time to look these over. Make any corrections you need to make. Think about them. You're going to see these same problems showing up next time. Very, very similar problems coming up in concepts 21 and 22 on the next test. All right, if you have any questions, bring them to class.